Hello, welcome to my speaking notes. In this video, I am going to explain how to sketch the graph of irrational functions. So, rational functions are just functions that are quotients of polynomials. So, it's a fraction. In the numerator, you have a polynomial, and in the denominator, you have a polynomial. So here is how you can sketch the graph of a rational function. First of all, find out if you can determine the x and the y intercept. Now for the x-intercept, y is equal to 0. So this is the point where the graph crosses the x-axis. At that point, y is equal to 0. Now, when we equate this function to 0, we find that 0 is equal to 3, which is not possible. So this graph does not have an x-intercept. Now, for the y-intercept, the point at which the graph crosses the y-axis, x is equal to 0. So we substitute for x equal to 0 and y is equal to 3. So the graph will cross the y-axis at 0, 3. Next, we find the asymptotes. So asymptotes are just lines where the graph approaches. There's a vertical asymptote, horizontal asymptote, and the slant asymptote. The vertical asymptote occurs where the denominator is equal to 0. So you equate the denominator to 0. So x plus 1 equal to 0, which implies x is equal to negative 1. For the horizontal asymptote, you analyze the degree of the numerator and the denominator. If the degree of the numerator is 1 less than the degree of the denominator, then y equal to 0 is the horizontal asymptote. So we put the vertical asymptote at 1 here and the horizontal asymptote y equal to 0. Now we can put the y-intercept, which is on 3, and we find other points because we want to know whether the graph will fall on the upper left or bottom left, right? So when x is negative 2, we find that y is negative 3. So we have a point here on the bottom left. So the graph will go that way as we have put. Now in this case, again, it is easy to see because the vertical asymptote is negative 1, so the graph will approach negative 1, and the horizontal asymptote is y equal to 0, so the graph will approach 0. But to verify that, we can put x equal to 2 so that our y is equal to 1, which is my point here. Then we can just connect like that. Okay, then this is done. The next case is interesting. So you have y is equal to x squared over x squared plus x minus 3. So the vertical asymptote again equate the denominator to 0, and this is not factorizable, so we use the quadratic formula. X is equal to 1.3 and x is negative 2.3. The horizontal asymptote, because the degree of the numerator is equal to the degree of the denominator, so we get the coefficient of x squared over x squared, which is just 1. Okay, so y is equal to 1 is the horizontal asymptote. Now we can go ahead and find the x-intercept. So at the x-intercept, y is equal to 0. And if we equate the whole function to 0, we find that x squared is equal to 0, so that x is equal to 0. So the x and the y-intercept is at 0, 0. Okay. Now we can put our points together. So we sketched the vertical asymptote, which is at so we sketched the vertical asymptote, which is x negative 2.3, and another one x equal to 1.3. Now the horizontal asymptote is y equal to 1, which is this one. So now then the x-intercept and the y-intercept is at the origin. Okay, so we can just find other points. So point beyond the vertical asymptote, which is negative 3, and point beyond the other vertical asymptote, which is 2. So when we evaluate the function at x equal to 2, we find that y is equal to 4 over 3, and at x is equal to -3, we find y is equal to 3. So plotting these points, you have a point here and a point here. But because these are asymptotes, so we are just going to draw a curve like that, and on the other side like that. Now on here, you can pick any point here and pick any point. You will see that the y value will be here, coordinates. So you can just draw a curve here, and we are done. All right, the final problem you have f of x is equal to x squared plus 2 over x minus 1. Now the vertical asymptote, the denominator equal to 0, so x is equal to 1. And for the domain, you just remove the vertical asymptote. You just remove the point of the vertical asymptote. So that is x. So that is all the values. So that is all real numbers except x equal to 1. Now the x-intercept, when y is equal to 0, you are finding that x squared plus 2 is equal to 0. So this will imply that x squared is equal to -2. But these are functions of real numbers, so you cannot have this case because this is a complex number. So this does not have an x-intercept. So y-intercept, x is equal to 0. So when we evaluate the function at 0, y is equal to -2. So that is 0, -2. Okay. Now we can notice one thing, that the degree of the numerator is greater than the degree of the denominator. So we just divide x squared plus 2 divided by x minus 1. So that is x plus 1 with the remainder 3. So that is x plus 1, the remainder is 3. So when we divide, the quotient is x plus 1 and the remainder is 3 over x plus 1. So y is equal to x plus 1 is the slant asymptote. So sketching, this is the line here, and the vertical asymptote was 1. Any other points? When x is -1, y is -3 over 2. So you have some point here. And when x is 2, y is 6, which is some point here. So you can just connect that, and this will be that. So that's it.